In this second video, we are going to talk about electronegativity in details and why electronegativity. We need the knowledge of electronegativity, preferably those values, the electronegativity values, because there is a simple rule of determining whether the bond is non-polar covalent or polar covalent. Now, electronegativity difference between two covalently bonded atoms determine the nature of the covalent bond. So when we talk about bond polarity, is the bond polar or non-polar? Of course, we are going to see what that really means. Bond polarity, non-polar and polar covalent bonds. Now we realize that if the electronegativity difference between two covalently bonded atoms is less or equal to 4, this implies that the bond, the covalent bond between those two atoms will be a non-polar covalent bond. Of course, we are saying it vaguely, but it's a good measure. For example, when you look at this example, when carbon is bonded to another carbon atom, carbon has an electronegativity value of 2.5. And so the electronegativity difference between two carbon atoms will be 2.5 minus 2.5, which is 0. The electronegativity difference between two hydrogen atoms, the bond between two hydrogen atoms will be essentially non-polar because the electronegativity difference is 0. Likewise, as long as the atoms on either side of the covalent bond are the same, the electronegativity difference will be 0, and that covalent bond will be non-polar. What does that mean? It simply means that the shared pair of electrons is shared equally. The electron density of that bond is uniform. So non-polar covalent bonds have a uniform electron density. That's very, very important to note. Let us also look at another example. In this example, carbon is bonded to hydrogen. Here, the atoms on either sides of the covalent bond are not the same atoms, carbon and hydrogen. The electronegativity of carbon is 2.5 and that of hydrogen is 2.1, and so the difference is 0.4. Now notice that if the electronegativity difference between the two covalently bonded atoms is less or equal to 0.4, then that bond is considered to be essentially non-polar. In this case, the carbon-hydrogen bond is essentially non-polar. But let me make a small clarification here. The carbon-hydrogen bond is not always the same wherever you find it. For example, the carbon-hydrogen bond in alkanes is different from the carbon-hydrogen bond in alkynes, where the carbon atom is actually forming a triple bond. We shall later on see that that carbon atom is called an sp, or it's called sp hybridized carbon. That bond is slightly more polar than the carbon-hydrogen bond in alkanes. So here I'm concentrating on the carbon-hydrogen bond in alkanes. This carbon-hydrogen bond is essentially non-polar. And of course, later on we realize that this explains why alkanes are generally unreactive. First of all, these two atoms are small, carbon and hydrogen. And therefore, their covalent bond is short. And if the bond is short, it means that it's strong. The shorter the bond, the stronger it is. Of course, there are exceptions here. When you look at, say, the fluorine molecule, the bond is not strong, even though it's very short. There are reasons to that, for that. Now here, we see that in alkanes, the carbon-hydrogen bond is short and very strong. And that bond is also non-polar. So we don't have slightly positive centers and slightly negative centers. There is a fairly equal distribution of electron density in that carbon-hydrogen bond. Yeah. So electronegativity difference is very important in determining the nature of bonds. For a bond to be considered nonpolar, the electronegativity difference between the two covalently bonded atoms should be less or equal to 0.4. Otherwise, the bond is polar. So we are going to continue in our next video with this concept of electronegativity.